Hello, welcome again to another programming session with C. So in the last video we talked about conditional statements, at least the second part of conditional statements, dealing with the switch case default, right? So we explained how similar it was to the if else, and at the end we took an example. So if you're not too familiar, I'd suggest you go back to the previous video and then do a refresher, and then you come back to this. Okay, so in this video we'll be looking at what we call loops, right, or iteration as it's generally called. So the whole concept of iteration is you have let's say to perform some codes a number of times, right, the same set of instructions a number of times. So instead of just writing it, let's say about 10 times, what we do is that we use this loops to write the code once and then specify how many times we want the code to be repeated. So that's what basically loops are about. It helps us to do repetition in code. Okay, so let's go to code blocks and then see what we are looking at. Right, so yes, we'll be starting with what loops are in general and why they are important. We'll look at the types of loops that exist in C. We'll look at the general structure of a loop. We'll look at what we call loop control statements and then usage of loops. So if all this doesn't make sense, don't worry, we're about to start. Okay, so now remember initially I said loops, right? So we can sort of explain loops as let's just say they are constructs that allow for code to be repeated, right? So anytime you hear loops, even in plain English, that's what a loop is, right? Something that goes round and round. It has no sort of end. Okay. So loops are constructs that allow for code to be repeated, right? That's the general explanation. So instead of typing, let's say 10 lines of code, let's say you have 10 lines of code that does a certain computation, right? And then you needed to do 100 of those computations, right? One alternative that you can type out 100 those 10 lines 100 times, which will give you about 1,000 statements for just a single calculation. Or what you can do is that you'd put those 10 lines into a loop and then tell the loop to run 100 times, right? Now that is just much shorter because you have about 12 lines in total and then it's still doing the same work as the previous 1,000, right? Okay. So let's just start those. That's basically what loops are and then why they are important. So now let's look at the types of loops we have in C, right? So the first one we have is what we call the for loop, right? So and then the next one is the while loop, and then the last one we have the do while loop. Okay, so we'll start with the for loops. So let me just write out a simple for loop statement and then we'll explain what is going on. Okay, so int I equals 0. So for I less than 10, I plus plus. So in here I'm going to tell it to print this is a loop, for loop, right? So you have that. So now let's explain what I've written over here. So this is what we call the for loop, right? So the for loop, think of the for loop this way. For any time this, what is inside this parenthesis is true, run whatever is inside the braces. I hope that's clear. Now what is inside the parenthesis here, that is what controls how many times the loop should run. Remember we said that loops are constructs that allow for code to be repeated, right? So this in here, the parenthesis, is what controls the number of times that the loop should run, and then whatever is in the braces is what should be done that number of times, right? So we have our condition, our controller over here, and then we have our statements that we want to perform inside the brace, right? So before I go deep into it, let me just run it for you to see what we'll get. So if I switch to the output window, now let's look. You remember we just wrote the statement once, but we have it printing about 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, right? Now this is what a loop does. We just wrote one statement, but because the controller part of it tells it to run for 9 times, that is what happens. So now let's go back and see why it is running for 9 times. Okay, so with the for loop, if you take this controller part, right, it is split into 3 different parts, right? So this very first part where you have the assignment going on, that is what we call the initializer, right? So that's the first part before this semicolon here. So the second part, this is actually the condition. So we have, let's just put O1 here, or just 1, right? So the second part is the condition. So this is the same conditions we treated in the past 2 videos. And then the third part, which is the last part after this semicolon, is what we call the iterator. Sorry. Agreed. So let's see what these 3 things do. So think of anytime a loop is running, right, the thing that controls it is a count, or the variable that controls how many times the loop is run is basically a counter variable. Basically something that counts a number of times, and then when it is got into a certain condition, it stops, right? So that's basically what you are doing. You've created a variable called I, which is going to be our counting variable. So the initializer sets or tells it simply sets the starting point of that counter, right? So initializer, as the name implies, it initializes the counter for the loop. So with this, we are telling it to start at I equals 0, meaning start your counting from 0. That's basically what the initializer does. Now let's look at this second part, the condition. The condition, you can think of it as controlling where the loop should stop. Sorry. Sorry. Right. So if we look at it, we are telling it that stop when, okay, one thing you need to know is that for any loop that you have, the loop will continue running as long as this condition is true, right? So anytime let's say it runs this printf statement once, it is going to come back to line 25, evaluate this condition, and then run again, depending on whatever the value of I is. So if I is starting from 0, it will print once, come back here, come and check, is the value of I less than 10? So in this case, I is still 0, right? So 0 is less than 10, making this condition true. And then it runs again. And then it does that until it stops. So this 10 simply tells it that if I is equal to or beyond 10, that means this condition becomes false, and then you can stop. So the condition controls where the loop should stop, right? And then finally the iterator. That is the part that controls how the counting is done, or controls how the counting is done, right? So now let's fully explain this again. We have our counting variable I. So the counters or the counting variable are most always integers. So the int, a float is not really something you'd want to use for this. Just something you should name it. So I starts from 0, right? And then it will check the condition. Is I less than 10? So 0 is less than 10. That means this loop or this statement printf is going to be executed once. So when it finishes executing, it will come back to the 25, which is the for loop again. But this time it will increase, or it will perform whatever the iterator says it should do. Remember, the iterator is controlling how the counting is done, right? So anytime you see I plus plus, is simply a shorthand for I is equal to I plus 1, right? So meaning increment the value of I by 1. So I was initially 0, so after I plus plus executes, I will have a value of 1, right? So now the value of I is 1, then it will come and check the condition again. Is the condition true? 1 is less than 10, so that makes our condition true. That means it will come and execute this printf statement again. and it will come back, increment the, or do the, it will run the iterator. So the iterator increases it by 1, and then it checks the condition. So it keeps on doing that until it gets to a point where the value of I makes this condition false, and then the loop ends over there, right? So the loop is controlled, or the where it should stop is controlled by the condition, and then the iterator tells it how to do the counting. So in this case, we are just incrementing by a value of 1, right? You can also increment by a value of 2, or any value that you want. So assuming I wanted to increase this every time by a value of 2, and I'll simply write this, right? So writing this statement is also equivalent to writing I is equal to I plus 2. Right. So this is just, you can't write this assignment statement here, but using these things, the increment and decrement operators, you can use them. So I'll just go back to my I plus plus, right? So that means this thing is starting from 0. It will execute at 0, execute at 1, 2, 3 until it gets to a value of 9, right? So that means it should print out 10 times. Okay. So now let's go back and count how many times this thing runs. So we said it starts from 0 all the way to 9. So let's see. So this is the first time it prints out. So this is the value I equals 0. This I equals 1, I equals 2, 3, 4, 5, 6, 7, 8, and then 9. Right? So at this point, the value of I is 9. So that means if it goes to run the iterator again, right? The iterator will send I to a value of 10. Now 10 makes this condition false. I hope that's clear. So because 10 makes it false, that means at the value I equals 10, this for loop will stop executing, and it will no longer run this. So it will now come after the the braces, and then continue executing whatever was here. So it has finished the repetition that it was doing, and then it is now continuing with the rest of the code. So you've seen how it prints out this statement 10 times, even though we just wrote it once, right? Okay, so let's change this a bit. Let's say I wanted to actually see what the value of I was while the loop is running, right? So using what we learned on printing of variables, I'll just use the format specifier for an integer, and then put the value of I. So I hope this is clear. So this way I can see whatever the value of I is as the loop is running, right? So let's also run this again and then see. Let's go to our output. And indeed we can see that I starts from a value of 0, goes to 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So at the point where I equals 10, the condition becomes false, and then the loop has stopped. That's why we are not seeing an I with a value of 10. So this runs 10 times actually, from 0 to 9. So I hope the for loop kind of makes sense. If you don't fully understand it, you can just go back and then watch that part again. But basically this is how the for loop works, right? You always start with your for statement, and then into parentheses you put in your initializer, you put in your condition, you put in your iterator, and then whatever you want to be executed any number of times, right? So even with this, let's see a simple program that we can write just with this for loop. So let's say I wanted to write a program that calculates or prints out the square of numbers from 0 to 9, meaning I want to see 0 squared, I want to see 1 squared, 2 squared, 3 squared, and so on and so forth up to 9, right? So all I would need to do is simply I can perform a calculation here, like so int square equals I multiplied by I, and then I print out the value of the square, right? So this is a very simple program. So I'm just going to remove this from there. So meaning for each time you are running the loop, multiply I by I and then print out the value, right? So let's run this and then go and see our output. So we have the square of 0 to be 0, square of 1 to be 1, 2 squared is 4, 3 squared is 9, and so on and so forth, up to the value of 9 squared, which is 81. So this is what loops enables us to do. Because I'm performing the same operation, which is just I multiplied by I, I can use a for loop to control what the value of I is, and then I can do whatever I need to do with it, right? Now let's say I wanted to do an increment of 2. So I'd write something like this. So now if we should run this, alright, if we should run this code, we should only see about 5 printouts or 5 statements being printed out, right? So it started from 0, so 0 squared is 0, but this time we did I plus equal to 2. So that means the next value of the iteration is going to be, well, it's going to be 2, right? So that means 2 squared is 4. So 2, it does another I plus equal to 2. That means I get a value of 4. 4 squared, which is 16. I do plus 2 again, I get 6. 6 squared is 32. And then I do plus 2 again, I get 8. 8 squared is 64, right? So now doing another plus equal to 2 means that the value is going to go to 10. And remember, 10 makes the condition false. Hence, the loop is ending over there. So I hope the for loop statement or the use of the for loop makes sense. So always have your initializer, always have your condition, always have your iterator, right? Now there's a lot more you can do with the for loop. You can actually use the for loop to simulate the behavior of the rest, which are the while and then the do while. But that's something I would leave for you to find out. Right now we are supposed to just learn the basics of loops, right? Okay, so we've seen the for loop. And the good thing about this is that the structure or the general concept of the for loops is similar to that of while and do while, right? So let's see how the while loop works. So let's say you were making a statement. While let's say you were running a race, right? I can make a statement like, while I still have energy, I will continue running, right? So that statement you made, while I still have energy, that I have energy is your condition there. As long as that condition is true, whatever you want to do, you keep doing it. In this case, the running. So while I have energy is equal to true, keep on running. So the moment I have energy becomes false, that means I'm going to stop running. That's exactly how it works here as well, right? So I'll do something like, so let's just write a simple while loop. So I'll declare another variable, call it j, start j from 0. So I'm going to say while j is less than maybe 10, right? So this one you also put your statement into the braces. So let's say we'll print out this is a while loop. Right? Okay, so let's analyze what we've written. So again, because it's a loop, I've declared another counter variable j. I've initialized it to 0. Sorry, I meant I've initialized it to 0, not 0. And it is an integer, right? So with the while loop, the only thing the while loop requires is the condition. The while loop itself doesn't take the initializer or the iterator, right? So you see that we've done the initialization over here, but the while loop only takes the condition. So while this condition is true, it is going to keep on executing, right? So because the while loop doesn't take care of the initializer and iterator, we have to do those things ourselves, else we can get stuck in what is known as the infinite loop. I'll explain that later. So I've done my initializer. This is basically an initializer. It's telling the counter that starts from a value of 0. My condition here is checking or it's basically a check for this while loop, and then I would want to do my while loop, my iterator inside the loop, not outside, so that anytime the loop runs, it runs the iterator as well, right? So over here I'm going to say j is equal to j plus 1. So you can also write j plus plus if that makes sense. So this is the same as writing j plus plus, right? But I'm just going to leave it like this. Okay, so let's run this as well and then see what we get, right? So I'm switching over to my output screen. So this side is for the for loop. Now let's look at this for loop. Right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 10 times. This is a while loop. because we did our iterator inside, anytime the loop runs, it increases the value of j by 1, and so on and so forth. You can see how very similar it is to the for loop, except it doesn't manage the iterator and then the initializer for you. You have to do those ones. So in this case, this is our iterator, right? So now I mentioned something called the infinite loop. Now that is actually a problem if you encounter it, because an infinite loop, as the name implies, is a loop that runs infinitely, meaning once it starts, it doesn't end. So something like that can happen if you forget to bring your iterator inside a while loop. So that means, let's analyze something. J starts from 0, right? You are saying the condition is j less than 10. Okay. So now if I print this value and I come back to check this condition, j is still at the same value it was, which is 0. Meaning that this condition is still true. I run this again, come and check it. J is still at a value of 0. It is still true, right? So that means because this, with the lack of an iterator here, this condition is always going to be true, and that means this loop is never going to end, right? So in some, this is not a good thing to happen. If you end it early, you can prevent problem, but if you let an infinite loop run long enough, it can actually make your PC stop responding, and you have to force restart it. As I've seen this a number of times. So now let's run this and then see. So I'm going to switch over to my output screen. So you can see that the program is running. It's not actually ending. If it ended, we would have seen that statement at the bottom here that press any key to continue. This loop is running and it's not ending, right? So to terminate a while loop whilst it is still in operation, make sure the focus is inside the command window and press and hold Ctrl and C. So you might have to do it twice for it to stop, right? So that's how you can forcefully terminate a program that is running if you use the Ctrl C inside the command window, right? So that's the problem that we have with a loop. If you forget to bring the iterator or anything that is going to iterate that variable, it is going to give you an infinite loop, right? So forgetting the iterator causes an infinite loop. Okay, so now let's look at another thing. Forgetting the iterator, yes, causes an infinite loop, but also putting in the wrong iterator will also give you an infinite loop, right? So now let's say I made an iterator. An iterator is simply a statement that changes the value of a variable, that's all. So now let's say I did something like this, j equals j minus 1. You can obviously see that from 0, this thing is going to go to -1 and all the way to -infinity. And all those values also make this condition true. That means even though we have an iterator here, it is not going in a direction that will eventually make this false, right? This is always going to make this condition true, because -1 is less than 10, -2 is less than 10, and so on and so forth. -infinity is also less than 10, right? So that means we'll modify this statement here, forgetting the iterator or using the wrong kind of iterator causes an infinite loop, right? So if I run this, it's still going to exhibit the same behavior we had again. So I'm just going to leave this there. So please don't forget, using the wrong iterator or forgetting it altogether will cause an infinite loop. Okay. So that's basically how the while loop works. It just uses a condition, so you have to take care of your initializer and your iterator by yourself, right? Okay, so if you look at the for loop and then the while loop, right, one thing you should notice that with for and while, they always check the condition before the loop starts, right? So let me take it again. With the for and then the while loop, the two of them always check their conditions before they even start the loop altogether. So let's say this for loop, I started I with a value of 100. Right, so it is going to compare, it's going to use I is equal to 100 to check this condition. Is 100 less than 10? Obviously that is a false statement, so it doesn't even enter the loop to run, right? So let's illustrate this to see. So if I go back to my output scene, at the very top you can see that nothing executed for the how do you call it, the for loop. This is the very beginning, meaning the for loop was skipped entirely because the condition I started with was already false. So I hope you understand. The same thing goes for the while loop. So maybe some people are doubting Thomas's, so let's just demonstrate it as well. So if I start this, let's say I also put j at 100, right? That means we expect that when you run it, we'll not even see anything for both of them. So let's go to our output and verify. So you can see, because both conditions are false, nothing was even shown, and then the program has just ended, right? So that is what we mean by the for and then the while loop. They always check their conditions before they start. So now that we've seen that, let's go to the last type of loop in C, called the do while. So the do while is similar, almost similar to the while loop, except that it actually runs once before checking the condition. So let's define another counter variable called 0 here. So in this statement, we would print, I don't know, this is a do while loop, right? So this is the structure for the do while. So basically do whatever is in the braces while this condition is true. I hope it makes sense. So do whatever is in the braces while the condition in the parentheses is true, right? So because the do statement comes before the while, it will do this statement at least once and then come and check the condition. So if the condition is true, then it will continue again. But if the condition is false, then it's going to stop. But it has already run once, right? Okay, so let's run this as well and then see what we get. So you can see that we are getting a good old infinite loop problem again, right? So I'm guessing you know why this happens, because we didn't put in our iterator. So don't forget. Okay, so I'm going to put in my iterator variable or statement here, so k plus plus. So after you print out, then increase k by a value of 1. Right, so now let's go back to our output screen. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as well, right? So that's what we expected, because we said while while k is less than 10, right? Okay, so now let's also do this for the do while loop. Let's make the condition false outright or from the start, and then let's see what happens. So remember, with the for and then the while, when we did this, we didn't see anything for them as well. So let's see how the do while is going to react. Okay, so the condition was false even before we started, but you can see that the do while has printed just one statement and it ended. So this is what I was saying initially. Do while will run once before how do you call it, checking the condition, right? So I hope that is clear. So we've looked at for loops, we've looked at while loops, we've looked at do while loops. So I hope everything at least makes a lot of sense. Right, so let's see what we are left with. We've done what loops are and why they are important, because they simply help us from they prevent us from repeating code, which will just make your work a lot. We've looked at the types of loops in C, which are the for loop, the while loop, and the do while. We've looked at the general structure of each of the loop, right? So with the for loop, we stated that is the first of all, your for statement comes, then in parentheses you have your initializer, your condition, and then your iterator. And then the while loop just cares about the condition, so you have to manage the initializer and iterator yourself. And then the do while loop, which is very similar to the while loop, but it just does or executes once before it checks, because the do statement comes first, right? Okay. So now let's look at control statements in loops. So if at this point, if you still don't understand something from the beginning part of this video, I'd recommend you pause or you take note of where you've reached, go back and start watching again, practice these examples that we typed out, right? And I think you should be good to go. So grasp that, don't rush, just take your time. It can be a bit confusing to sink in. So if you're not clear on anything, just go back to the beginning or wherever you were confused from and then watch. And then when you come here, then you continue. So we are going to look at what we call the loop control statements. Sorry. I'm sorry for the throat clearing. I've had a bit of a sore throat this morning, so please forgive me. Okay. Sorry. So now we can see that with the for loop, right? So I'm going to revert them back to the initial conditions. And then we have this. Okay. So with the for loop, right, we can see that it starts here, it's supposed to end here, and then this is how it should or how we should do the counting. But now let's say you were counting from your original controller, or your original initializer started from 0. The condition was I less than 10, and we have, let's change this back to I plus plus. So we have plus equal to 1. Sorry. So now let's say you had this. So we've already seen that this is going to do this or these two statements 10 times, right? But what if you had a point where you wanted to stop prematurely? In other words, let's say when I get to a value of 5, for some reason I want to stop over there. So some of you might be thinking, obviously you can just change this. Well, that is true actually, but there are cases in which you'd have to declare an original ending point, but maybe when it gets to a certain value it should terminate over there, or the loop should stop over there, right? So if we wanted to do something like that, that's where the loop control statements is. Now the control statements that we have are the break, and then we have the continue. There used to be another, or there is a go-to statement, but this is no longer recommended for use, so we just use the break and continue. But I'll check on the new standards of C and then see if it is still in it. If it is, then I think I'll make another video to cover that one as well, right? Okay. So sorry for this. So let's, yeah, I'm just going to use this initial for loop to do the modification in. So now let's say we are doing all this, right? But if we get to a value of I equals 5, I want to end the entire loop over there, right? That is where the breaks wow. Sorry. Okay, so like I said, what if we wanted to run this original thing? So we are going from 0 to 10 or to 9, but when we get to I equals 5, I want to stop, right? So in that case, because you stated a condition there, when or if we get to I equals 5, then we stop over there. That's kind of the same way you'd write it, right? So from our conditional statement, I can put an if within a for loop. So if I equals 5, right, I want to end the loop. So we can then bring what we call the break statement. Right. So the break statement, if it is used within a loop, it's only valid, the break is only valid when using it in either a switch case or a loop, but any other point it would, the compiler will flag an error. Okay. So when I get to 5, right, I want the loop to stop. So because this break is in this for loop, it is going to terminate this loop at where it is. So in other words, when I gets to 5, end this for loop, right? So if the logic, if we understand this logic, that means it's going to print out the square of 0, the square of 1, the square of 2, the square of 3, and then the square of 4. I hope you agree. Because 5, if it gets to 5, this condition becomes true, and then it will enter the if statement and execute the break command. Okay, so let's run this and then see what we have. Okay, so going to our output scene, you can see that we have, the square root of 0 is 0, square root of 1 is 1, square root of 2 is 4, square root of 3 is 9, and then the square root of 4 is 16. So because it has gotten to the value I equals 5, the break statement has been executed, and then the for loop is terminated over there, right? So that is how the break statement works. You can use it to terminate a loop prematurely, or in other words, before it actually gets to where the condition said it should get to. So that is the break statement. It's simply used to end a loop, that's all. Okay, so in the second example, we'll do it, or the second, we've looked at the break statement. So with the continue statement, I'll do it in this while loop part. So now let's say within this while loop, right, I wanted to skip, let's say I is running from 0 to 9, right? So if it gets to 6, just skip 6 and then continue to 7. So you can see the statement I just made this: skip 6 and continue to the next value, which is 7. So anytime you want to skip operations in a loop, or you want to skip the operations of some either one value or multiple values, you can use the continue statement, right? So let's say I did something like this: if j equals 5, right? Simply continue. I hope it's clear. That means this loop originally is supposed to print this is a while loop. So let's just add a number to it, which is just the value of I, so that we see which I we are dealing with. Okay. So this is going to print this is a while loop 0, this is a while loop 1, all the way to this is a while loop 9. But we are telling it that when you get to j equals 5, right, continue. So anytime you use a continue statement, everything that is below this continue statement up to the end of the for loop is going to be skipped, and then the while loop will iterate on to the next value and continue, right? So I hope that kind of makes sense. So if you get to 5, continue. That's all we are doing, right? So now if you look at this, even this can cause an infinite loop. Now let me explain why. Please listen carefully. Look at where I've put the if statement. If j is equal to 5, continue. That means it's going to skip this printf statement. It is also going to skip the iterator as well. I hope you are getting it. So that means because the iterator has not been executed, j is still going to remain at a value of 5, right? So when it comes back to the for loop to start it again, since j has a value of 5, it is going to continue again. It will come back and still continue, right? So if you really don't believe me, so that means we are, when it gets to j equals, or this is a while loop 4, it's going to start an infinite session from there, right? So let's run this and then see. Also when it gets to 5. Let's see. So we're going to the output. So you can see it has just printed about 5 times, and then you can see that this blinking cursor is there, right? It hasn't brought that please press any key to continue. That means it's running an infinite loop right there. So I'm going to use Ctrl C again to end it, and then go back to the code, right? So I think I was supposed to put j here. That's why you kept on seeing a value of 5. So even using continue state, depending on how you place the statement, you can actually cause an infinite loop if you are not careful. So one thing we can do is that before we continue, we just increment the value by 1. So this way we don't cause any infinite loop. So when we are about to continue, increase j by a value of 1 so that j is at 6. So that when it skips these 2 lines and then comes to start again, this condition is now false, right? So you can rewind a bit to listen to that part about the continue statement causing an infinite loop. Okay, so I'm going to run this again, and then let's go back to the output, right? So we can see that we've done 0, 1, 2, 3, 4, but we skipped the value of 5 and gone to 6, 7, 8, and 9. So that is what the continue statement does. While the break statement will terminate the loop at that point, the continue statement will just skip that current iteration or skip any other lines below it and then move on to the next iteration. So I hope that is clear. Okay, so we've looked at the continue and break statements, or how we control loops, right? So like I keep saying, this is not really a matter of just looking at this video and say you understand it. Understanding what a loop is, understanding what the types of loops are, understanding the structure of loops, the break and continue, that all that is one thing. Actually seeing a problem and knowing that I have to use for loops or I have to use a while loop, that is where the real task lies, right? Because in projects that you'll be doing, no one is going to pay you to write him a for loop statement. No. Someone is going to pay you to write, maybe build a website, and you have to know when to use, or maybe build him a desktop application that does something useful that he can go and do useful to get money or something, right? So the problem is not how do you call it, remembering what a for loop is. It's not a matter of saying that I know how to write a break statement and continue. It's a matter of seeing the problem and knowing that you have to use a break or continue statement. That is where the real issue lies. And you cannot build experience unless you practice. It's like a language. If you don't speak it, you not really be fluent in it. Okay. So we've looked at loop control statements, right? This is basically an introductory part of for loops. Like I said, there's a whole lot loops can be used for, and you get it by doing examples, reading more, practicing, right? If you hit a problem, I mean, there are numerous websites you can go to see if someone has found a solution. A popular one is Stack Overflow. Maybe some of you might have heard of it, but it's a very popular site where if you are stuck with something, you can go and get help. Okay, so we've seen all this. This is good. So like the past 3 videos I've been doing, the best way to solidify all this would be to take maybe a practical question and then try and see if you can handle it, right? So let's go to our programming projects part. Okay, so I'm using the DS Malik book, C Programming a Modern C Programming a Modern Approach. This is not DS Malik, I think that was for C++. But I'm not sure who the author is, but yeah, that's the book I'm using. Okay, and the first question looks, or the first project looks interesting. Now this can be an application for, let's say you had a class list, right? And then you were entering the values into a program, and you want the program to be able to calculate whose marks was the highest. This and a program that can do all this, because it says you have to write a program that finds the largest in a series of numbers entered by the user. The program must prompt the user to enter the numbers one by one. Then when the user enters 0 or a negative number, the program, it should stop accepting input and then display the largest non-negative number entered, right? So the numbers aren't necessarily integers, right? So this is something that someone can pay you to do. In this place, they didn't tell you that you have to use a conditional statement or an iteration statement or anything. This is where your experience comes in. Yeah. So let's just tackle this problem and then see how we would approach it. Okay, so I'll clear what I've done within the main statement. Hopefully you have yours there, and then we'll start with this whole thing. Okay, so we need to enter a series of numbers, right? So we'll obviously need some variables to store the values. Okay, so let's switch back to code. So I've taken out everything that I had in my main, so you can just comment yours there, but I like the space over there. So since they gave us a notice that the numbers are not necessarily integers, that means I'll use a float for this so that I can accept decimal numbers and stuff, right? So I'll call the first one input, and then I would also declare another variable that will hold the max input. So I'll enter into the input, and then this is what will be tracking the current maximum that I've entered. Okay. So I'll just give this maybe a value of 1. You'd see why later. So while input, right, is greater than 0. So I hope you understand why I did this. The condition for the while loop is not, or does not necessarily need to be an integer. It can even be a character, but the point is that you should have a condition there. So the for loop, that it's kind of mandatory that the counter should be an integer, but the while loop does not have that limitation, right? So let's analyze why I'm doing this. The question says, or the problem said that I should keep on entering numbers, right, while the number entered is not a 0 or a negative number, meaning this thing can only accept positive. I mean, the program should the loop should keep on repeating the same process of asking me for input while my input is positive. Do we get it? So that is why the condition is over there. This is the condition for a positive number once it is greater than 0, right? So that was the reason I initialized my input to 1, because 1 is a positive number, and then this makes this condition true. So that means the while loop will begin executing, right? So over here I would write a printf statement. So enter a number. Sorry. And then I'll use my scanf statement. So because we are dealing with wow, I am really sorry for this. Because we are using a float, I'm going to use %f and then my ampersand into my input, right? So that means this program is going to keep on asking me for a number. So let's run it for now and then see what we have. So going back to our output, so it's always a good thing that anytime you write a small piece of code, you test it before writing more, so that when the errors come, they are manageable to deal with, right? So now if I do this 12, because 12 is positive, that input greater than 0 is at work, and then the loop is continuing to run. So 49, 23.42. So I can keep on doing this forever, but the moment I input a 0 or a negative number, now the loop has ended. So I hope we get the concept of why it's behaving like this. Okay. So at least the input part works, right? So now let's actually write the part to calculate the maximum. So if I give you two numbers, right, how do you know which of them is maximum? You simply check whether A is greater than B or B is greater than A. So if A is greater than B, then that means A is the maximum. If B is also greater than A, that means B is the maximum, right? So we'll start an initial max input from 0. So we are starting that the maximum is 0. So because we have two numbers here, like we said it earlier, if A is greater than B, that means A is the maximum. But if B is greater than A, that means B is the maximum, right? So that's the same condition we write over there. So if max input is greater, in this case, sorry, if the input that we've entered is greater than the current maximum input, that means assign the maximum input with the value of whatever you entered. So I hope this makes sense. So we are using a conditional statement within a loop as well. So like I said, a loop can contain anything that you want to be repeated. So a loop can also contain another loop, something we call nested loops. That can become a bit tricky to work with. So let's start with this for now. But I hope you understand this algorithm right here. If the number that I've entered, which is the input, is greater than what I currently have as my maximum, then that means my maximum is equal to what I entered, right? Okay. So then after the loop ends, I can now print out my result. So printf, the largest number entered was, and we'll put maybe percentage .2f because I want 2 decimal places, and I'll print out the value of max input. Right, so let's run this and then see what we get. So I start with 12, start with 43, start with 90, I start with, let's say, 80. So at this point 90 should be my current maximum, right? So 82 is not greater than 90, so maximum input is still 90. And then let's input 0 to end everything. So we expect that the maximum input should be 90, right? So if I press enter, great, so we see that the maximum input was indeed 90, right? So I'll run this program again, and then so this time let's use the input from the book. So the book started with 60, and then they did 38.3, and then they did 4.89, and then they did 100.62, and then maybe 75.2295, and then after that they did a 0. So at this point we expect that our maximum is 100.62, right? So if I press my enter now, you can see the maximum was 100.62. Right, so I hope this whole thing has made a lot of sense. Loops simply prevent us from doing the same thing over and manually doing the same thing over and over again. We just put what we want to do into a loop, tell the loop how many times it should run, and then it does it for us. So if I'd recommend you watch this video again, and like I said, keep practicing the example that we typed out, because practice makes perfect, or almost perfect, as my mom would say. And then try and see if you can go through this example again, understand what is going on. Don't be too concerned about this, like what exactly you are typing. Understand what is happening in this program that you are writing. So every program and then how you write it. Actually, in this case, this is how we wrote it. Like I said, loops, this is just the beginning of loops for you. When you finish this, I would encourage you to delve deeper into it, because loops you can use to achieve a whole lot more, right? Okay, so as usual, if there are any questions, suggestions, any comments basically, please leave it in the comment box, and I'll do well to respond to each and every one of you. So please, if you like this video, please click the like, as it helps promote my content, and subscribe to get notifications. Subscribe and turn notifications on to get notified when I upload a new video. And if God permits, we'll see each other in the next video. Alright, have a nice evening.